Today, we're going to talk about bubble sort, one of the most basic and easy to understand sorting algorithms. Even though it's not the most efficient for large datasets, it's a great way to get started with sorting and understand the concept of comparing and swapping elements. So, what exactly is bubble sort? Imagine you have a list of numbers that you need to sort in ascending order. Bubble sort works by repeatedly stepping through the list, comparing adjacent elements, and swapping them if they are in the wrong order. It continues this process until no more swaps are needed. Once the largest element bubble at the end, it again starts with the comparison from first position. This process continues until the elements are arranged in the correct order. So, the larger elements keep rising to their correct position with each pass, and this bubbling effect is what gives the algorithm its name. That is bubble sort. Is it a bit tricky to grasp? Don't worry. Let's simplify it with a real-life example. Imagine sorting students by height, in ascending order, just like a teacher would do for a morning assembly. We have got 5 students: Jack, who's 160 centimeters tall; Clara, at 150 centimeters; Alex, who's 170 centimeters; Noah, at 140 centimeters; and Ryan, who's 165 centimeters. Imagine you are a teacher, and you have a group of students standing in a random order. You want to arrange them by height, from the shortest student to the tallest, so that the assembly looks neat and organized. One way to do this is by using bubble sort, where we repeatedly compare adjacent elements, in this case, students, and swap them if they are in the wrong order. Let's go through an example where a teacher uses bubble sort to sort students by height. The students are lined up in the following order. First, we have Jack at 160 centimeters, followed by Clara at 150 centimeters, Alex at 170 centimeters, Noah at 140 centimeters, and finally, Ryan at 165 centimeters. So, our initial array of heights looks like this. We begin by comparing the first 2 students, Jack and Clara. Is Jack taller than Clara? The answer is yes. So, we'll swap their positions. Jack will move to Clara's spot, and Clara will take Jack's place. Next, we compare Jack's height with Alex's. Is Jack taller than Alex? The answer is no, so we won't swap them, and we'll move on to the next comparison. Now we compare Alex and Noah. Is Alex taller than Noah? Yes, he is. So, we'll swap their position. Alex will move to Noah's spot, and Noah will take Alex's place. Next, we compare Alex and Ryan. Is Alex taller than Ryan? The answer is yes. So, we'll swap their positions. Alex will move to Ryan's spot, and Ryan will take Alex's place. After completing our first pass, the tallest student, Alex, has now moved to the last position. So, the current order is Clara, Jack, Noah, Ryan, and Alex. Our array of heights now looks like this. Now, we'll start again from the first position and repeat the process to further sort the heights. In Pass 2, we compare the first 2 students, Clara and Jack. Is Clara taller than Jack? The answer is no, so we won't swap them, and we move on to the next comparison. Next, we compare Jack and Noah. Is Jack taller than Noah? Yes, he is. So, we'll swap their positions. Jack will move to Noah's spot, and Noah will take Jack's place. Next, we compare Jack and Ryan. Is Jack taller than Ryan? The answer is no, so we won't swap them. The process stops here for this pass, and we don't need to check Alex, because we've already placed the tallest student, Alex, in the last position. After each pass, we reduce the number of positions we need to check by 1, because with each pass, the tallest student is being placed in their correct position, so there's no need to check them again. So, after pass 2, our new sequence is Clara, Noah, Jack, Ryan, and Alex. The array of heights now looks like this. Now, we'll start again from the first position and repeat the process to further sort the heights. In pass 3, we compare the first two students, Clara and Noah. Is Clara taller than Noah? Yes, she is. So, we'll swap their positions. Clara will move to Noah's spot, and Noah will take Clara's place. Next, we compare Clara and Jack. Is Clara taller than Jack? The answer is no, so we won't swap them. The process stops here, and we won't check Ryan and Alex because we've already placed both of the tallest students in their correct positions. So, after pass 3, our new sequence is Noah, Clara, Jack, Ryan, and Alex. The array of heights now looks like this. In pass 4, we compare the first two students, Noah and Clara. Is Noah taller than Clara? The answer is no, so we won't swap them. We'll stop here because we've already positioned the 3 tallest students. Since no swaps were made in this step, the process ends here, giving us the final result as required students arranged in ascending order of height. Let's see an algorithm. Let's break down the bubble sort algorithm step by step for you. Step 1, we start with the first element in the list. This will be our starting point. Step 2, now, we repeat the following steps until the entire list is sorted. We go through the list from beginning to end, comparing each pair of adjacent elements. If we find that the current element is bigger than the one next to it, we swap them. Step 3, after completing a full pass through the list, the largest unsorted element will have moved to its correct position at the end. Step 4, we then repeat the same process for the remaining unsorted elements. With each pass, we reduce the number of comparisons because the elements at the end are already in place. Step 5, finally, we stop when we complete a pass without making any swaps. That means the list is now completely sorted. Let's break down this bubble sort procedure in a way that's easy to understand, especially if you're just starting out with coding. We will see each part step by step. Step 1, setting up the procedure. The procedure starts with the line procedure bubble sort array. This means we're defining a procedure called bubble sort that will take an input called array, which is just a list of numbers we want to sort. Step 2, get the length of the array. Next, we have n equals length of array. Here, we're simply figuring out how many elements are in the list and storing that number in the variable n. For example, if the array has 5 numbers, n will be 5. Step 3, repeat until sorted. Then, we have the line repeat, which starts a loop that will keep running until the list is completely sorted. This loop will allow us to go through the list multiple times if needed. Step 4, initialize the swapped flag. Inside the loop, we set swapped equals false. This is a flag that helps us keep track of whether we made any swaps while going through the array. If no swaps are made, it means the array is already sorted, and we can stop the loop. Step 5, go through the array. Now, we have for I equals 0 to n minus 2. This line means we are going to look at each element in the list from the start to the second to last element. We stop at n minus 2 because we're always comparing each element to the next one. If we went all the way to the last element, there wouldn't be a next element to compare to. Step 6, compare and swap. The next part is if array of I is greater than array of I plus 1, then swap array of I with array of I plus 1. Here's what's happening. We check if the current element is greater than the one right next to it. If it is, we swap them, which means we switch their positions in the array. After the swap, we set swapped equals true, indicating that we made a swap. Step 7. Reduce the range. After we finish going through the entire array, we do n equals to n-1. This means we reduce the number of elements we're going to check in the next pass because the last element is already in the correct position. Step 8. Check if any swaps were made. The line until not swapped checks if the swapped flag is still false. If no swaps were made during the pass, it means the list is already sorted, and we can stop repeating. If swaps were made, we go back and repeat the steps. End of the procedure. And that's it. The end procedure line tells us that we've finished defining how the bubble sort works. So, in simple terms, bubble sort keeps going through the list, swapping numbers that are out of order, and reducing the number of elements to check with each pass. It stops when it can go through the list without making any swaps, meaning the list is fully sorted. And that's all about bubble sort. I hope this explanation made it easier for you to understand how it works. If you enjoyed this video, don't forget to hit the like button and subscribe to the channel for more content like this. Thank you so much for watching, and I'll see you in the next one.